Hello students. Now we are going to discuss the second chapter of class 10th chemistry, acids, bases and salts. So first of all we are going to understand acid. They are so in taste. They turn blue litmus to red. Third, they give H plus ions in aqueous solution. Acid corrodes metal. Now we are going to understand one by one. They are sour in taste, as we know, like lemon, oranges. They have sour in taste. Their taste are sour. This is the lemon or orange. They turn blue litmus to red. If this is the blue litmus, and the part which is contact with lemon turn into red. Now they give H plus ion in aqueous solution. H plus ion, like HCl gives H plus Cl minus ion. When HCl will break down in H plus ion and Cl minus ion. Here acid corrode metal. It's very common. All metals decay in the presence of acid. So acid destroy metals slowly. Now we are going to take some examples of acid. Strong acid. Strong acids are HCl, H2SO4, HNO3. They are the strong acid. They come into your syllabus. Like HCl, we have taken 100 molecule of HCl. Why we say this is the strong acid? HCl gives 100 H plus ion plus 100 Cl minus chloride ion. Cl minus ion or chloride ion. Here H plus ion, 100 H plus. That means this HCl completely break down into H plus and Cl minus ions. That's why it is a strong acid. Second example, H2SO4. 100 molecule of H2SO4 we have taken, and this 100 molecule break down into 100 H plus ion plus 100 HSO4 minus ion. That's why it is called strong acid, because molecule 100 molecules completely divided in its cation and anion. So this positive part is called cation or positive ion. This negative part are called anion or negative ion. So this is the strong acid. Now we are going to understand the weak acid. So what is weak acid? First of all, try to understand weak acid are natural acid, or we can say all natural acids are weak in nature. Acetic acid, we are going to write acetic acid CS3COOH. Oxalic acid and citric acid. Oxalic acid C2H2O4, citric acid C6H8O7. This is the example of weak acid. So why it is called weak acid? We have taken example of acetic acid for weak acid. If we have taken 100 molecules of CH3COOH and this molecules does not break down into total ions, like it is only 5 CH3COO minus plus 5 O plus 5 OH minus ions. So you can say here we have taken 100 molecules of acetic acid, but we find in solution only 5 molecules of CH3COO plus and 5 OH minus, and the remaining part 95 CH3COOH is found as a molecule we have taken in solution. So in weak acid there are 3 parts. What is cation, anion and molecules. In strong acid only 2 parts, cation and anion, or you can say positive ion or negative ion. Okay. Now base. What is the characteristics of base? They are better in taste. That means bases are better in taste. They turn red litmus to blue. They turn red litmus to blue. Next, they give OH minus ion in aqueous solution. Next, soapy in touch. When we touch base, we feel like soap. This is the. They give OH minus ion in aqueous solution. They turn red litmus to blue when litmus paper, the color of litmus paper is red. When it contact to base, its color become blue. So now we are going to take example. Strong base. Strong base are NaOH, KOH, CaOH whole twice. This is the strong base. Why we called it strong base? NaOH, we have taken 100 molecules of NaOH. It gives 100 Na plus 100 OH minus. Because 100 NaOH, that means the molecule we have taken 100, and it gives 100 cation and 100 anion, 100 positive ion and 100 negative ion. So a weak base in weak base like NH4OH, ammonium hydroxide, if we have taken 100 molecules of NH4OH, it has given only 7 NH4 plus 7 OH minus. And how many parts remain? 93 NH4 OH. So we can see in a weak base there are 3 parts. What is? This is the cation, this is the anion, and here is molecules. For strong base, only 2 parts, cation and anion in their solution. So now a term which come into the acid. Strong acid or concentrated acid. What is the meaning of concentrated acid? Concentrate means percentage of water, acid is high and percentage of water is low. This is the concentrated plus water. If we add concentrated acid in water, so one thing more, always we add acid into water, we never add water into acid. Here is water, we add acid, this is the right way. But in acid, if we adding water, it may be dangerous. So this is the wrong way and this is the right way to add acid. So one thing more, we are concentrated acid, we added water, it convert into dilute acid, and in dilute acid percentage of acid is less and percentage of water is more. So you can say this is the term concentrated acid and dilute acid. In concentrated acid, percentage of acid is more than water. In dilute, the percentage of acid is less than water. So now the next term we are going to add indicators. We are going to discuss indicators. What is the use of indicator? Why we introduce indicators? What was the reason? So the reason is, when we are going to check the acid, it is sour in taste, and base which is bitter in taste. It is not required every acid we check through taste, because it is dangerous. For that requirement we use indicators. We can check the lemon, we can check the oranges, but every acid we can check. We can check vinegar, but we cannot check H2SO4 is also acid, HCl is also acid, we cannot check because it is dangerous for us. So we use indicators, which is very useful, because through colors and smell they introduce they are acid or base. Now indicators, these are the substances which change their color or smell in different types of substances. Now we are going to understand the type of indicators. First is neutral indicator, second is synthetic indicator, and third is olfactory indicators. So now one by one we are going to discuss the indicators. The first is neutral indicator. So what is neutral indicator? These indicators found in nature in plants called neutral indicators, like litmus. Litmus is prepared by plant. So when for acid, litmus paper is going to test for acid. Here blue litmus paper, when contact with acid, it turn into red, and red litmus paper come into the contact of blue base, it turn into blue. Turmeric, haldi, when turmeric come into the contact of acid, there is no effect, that means yellow in color, their natural color. But when turmeric come into the contact of base, it turn red in color. So next is synthetic indicator. They are chemical substances. Here in synthetic indicator, they are chemical in substances. That means it is prepared in laboratory. For methylene orange, it is mentioned here methylene orange. When methylene orange come into the contact of acid, its color become red. Here is red. When methylene orange come into the contact of base, become yellow in color. Phenolphthalein, when phenolphthalein come into the contact of acid, here is colorless. It shows watercolor. That means there is no color. When phenolphthalein come into the contact of base, it shows yellow in color. Here yellow in color. When it come into the contact of acid phenolphthalein, it becomes colorless. Now olfactory indicators. So what is olfactory indicators? These substances have different odor in acid and base. When we apply olfactory indicators, this indicate through odor, जिसको हम महक कहते हैं, सुगंध कहते हैं. Olfactory indicator introduced by odor. Vanilla essence, it is used in ice cream for flavor. When vanilla essence come into the contact of acid, its fragrance, its smell increases. But it comes into the contact of base, there is no effect, no change. And clove, long, clove oil, long ka tel. When clove oil come into the contact of acid, its smell increases. But when clove come into the contact of base, its smell decreases.